Hey, we've now done 2 of the 3 log laws. We got the addition law, we got the subtraction law, and that leaves us with one more. And we can actually derive it again. I'm going to show you where it comes from. This is not a magic trick. If I have log base a of x squared, okay, we have, actually I can rewrite that and say, well, that's log base a of x times x. But now that we are armed with this addition law, I have multiplication inside of a logarithm. I could pull that apart and write it as 2 separate logarithms, log base a of x plus log base a of x. Nothing too fancy there. Then finally, if I'm adding 2 expressions that are exactly the same, that means there's 2 of them. So I could just rewrite that as log base a 2 times log base a of x. So let's look at the original one, and then let's look where we finished. Log base a of x squared will equal 2 times log base a of x. I could go through the exact same process, but guess what? Log base a of x cubed is the same thing as 3 times log base a of x. Do you pick up what I'm laying down? Hopefully you do. The exponent rule says this: if there's an exponent inside of a logarithm, you can pull that exponent off and multiply it out front. This 2 would get multiplied out front of the logarithm if it was a 3. And this is important now, because if for some reason we had, I don't know, log base 10 of 4 to the x power, armed with this we can say, well, it's an exponent inside of a logarithm, easy for me to say. I can pull that out front with multiplication, and it's no longer here. So where a second ago we had 4 to the x, I could never solve for x. I could never get x by itself. I can't divide by 4. I can't take a 4th root. There was no way to get x by itself until I strapped a logarithm to it. Log base 10 of 4 to the x. I could now pull that logarithm that was out of reach. I pulled it down out front with multiplication, and now I can solve for it. Logarithms. Moving on.